Those strange black and white squares are everywhere on restaurant tables, product packaging, ads, and tickets. With a quick scan, they instantly open websites, process payments, or reveal information. But what are they? And how can such small patterns hold so much data? These squares, called QR codes, are powerful digital tools. What looks random is actually a smart system designed for speed, accuracy, and reliability. And once you understand them, you'll never see them the same way again. The real origin of QR codes. QR codes were created in 1994 by a Japanese company called Denso Wave, a subsidiary of Toyota. The technology was originally developed for industrial use, not for everyday consumers. Toyota's manufacturing system required a faster way to track vehicle components on production lines. At the time, traditional barcodes were widely used, but they had major limitations. They could only store a small amount of information and could be scanned in only one direction. This made them inefficient for tracking thousands of parts moving through complex manufacturing processes. Engineers needed a system that could store more data, scan faster, and work from multiple angles. Their solution was a two-dimensional code, a grid of black and white squares readable both horizontally and vertically. This simple innovation allowed dramatically more information to be stored in a compact space. The result was the quick response code. Interestingly, the creators never expected QR codes to become a global standard. They were designed purely for factories and warehouses. But their speed, flexibility, and reliability eventually pushed them beyond industrial environments and into everyday life. Why QR codes look random but aren't? Finder patterns, the three large squares. The most recognizable feature of a QR code is the three large squares positioned at its corners. These are called finder patterns, and they help a scanner recognize the code instantly. Their main job is to show the device where the code begins and how it is oriented. Because of these markers, a QR code can be scanned sideways, upside down, or at an angle, and it will still work perfectly. Timing patterns, measuring the grid. Between the larger squares, you'll notice rows of alternating black and white dots. These are known as timing patterns. They help the scanner determine the size and spacing of the code's grid. Whether the code is printed large on a billboard or tiny on a receipt, timing patterns allow the device to calculate the correct dimensions. Alignment patterns, fixing distortion. QR codes are often printed on curved or uneven surfaces like bottles, packaging, or folded paper. This can distort the shape of the code. To compensate, QR codes include smaller squares called alignment patterns. These help the scanning software correct any distortion digitally, ensuring accurate reading even when the surface is not flat. Data modules, the real information. The smallest black and white squares in the code are called data modules. These are where the actual information is stored. To human eyes, they look random. To a device, they form a structured digital language. Each black square represents a binary 1, and each white square represents a 0. Together, these bits create encoded information that can represent text, numbers, links, or files. What happens when you scan a QR code? Scanning a QR code triggers a complex but extremely fast process inside your smartphone. First, the camera detects the finder patterns and identifies the object as a QR code. Then, it determines the code's orientation, size, and angle. Next, the phone reads timing and alignment patterns to reconstruct the grid precisely. Finally, the device interprets the binary data stored in the modules and converts it into usable information, a website link, contact details, payment request, or other content. All of this happens in less than a second, creating the illusion of instant digital interaction. How much information can a QR code store? One of the most impressive features of QR codes is their storage capacity. A standard QR code can contain over 4,000 alphanumeric characters, nearly 7,000 numeric digits, binary data such as small files or images. This enormous storage capacity explains why QR codes can handle complex tasks despite their small size. Why QR codes still work even when damaged. Perhaps the most surprising feature of QR codes is their resilience. Even if a code is scratched, dirty, faded, or partially destroyed, it can still function. This is possible because of a system called error correction. QR codes include built-in backup data that allows missing or damaged sections to be reconstructed. Depending on the error correction level used, up to 30% of a QR code can be missing, and it will still scan successfully. This durability makes QR codes ideal for outdoor advertising, tickets, packaging, and industrial environments where wear and tear are common. The smartphone revolution and QR code explosion. Although QR codes existed since the 1990s, their widespread adoption did not occur until smartphones became common. In the early years, scanning required special applications, limiting usage. But around 2017, major smartphone manufacturers integrated QR scanning directly into camera apps. Suddenly, anyone could scan a code instantly without installing additional software. This dramatically increased adoption worldwide. Then, in 2020, global circumstances accelerated their usage even further. Businesses and organizations sought contactless solutions for transactions and information sharing. Restaurants replaced physical menus with QR codes. Stores adopted QR-based payments. Events used QR codes for entry and verification. A tool originally designed for car factories became a universal digital interface. What QR codes can do today? QR codes are far more versatile than most people realize. Today they can open websites or mobile applications, process digital payments, share contact information, connect devices to Wi-Fi networks, display instructions or product details, track shipments and logistics, provide authentication or verification, store tickets and event passes. They act as a bridge between physical objects and digital information, allowing instant interaction between the real and virtual worlds. Dynamic QR codes. Modern QR technology has introduced an even more advanced version called dynamic QR codes. Unlike traditional QR codes, which contain fixed information, dynamic codes link to content that can be updated without changing the printed design. This allows businesses to modify menus, promotions, or information while keeping the same code in place. For example, a restaurant can update its menu daily, or an event organizer can change ticket details all through one printed QR code. This flexibility makes QR codes even more powerful as a communication tool. From factory tool to global symbol. The journey of QR codes reflects how technology evolves in unexpected ways. What began as a solution for tracking car parts in Japanese factories has become a universal system connecting the physical and digital worlds. They represent speed, convenience, and efficiency. They eliminate friction in everyday tasks, from making payments to accessing information. Despite their simple appearance, QR codes combine advanced mathematics, digital encoding, and error correction systems into a compact visual design. A technology hidden in plain sight. Most people scan QR codes automatically, rarely questioning how they work. Yet behind those simple black and white squares lies an elegant system of data storage, pattern recognition, and digital communication. They are not random patterns. They are carefully engineered digital gateways, tiny databases that connect physical spaces to the internet instantly. From industrial production lines to restaurant menus, from tickets to payments, QR codes have transformed how humans interact with technology. And as digital systems continue evolving, their role will likely expand even further. The next time you scan one, remember, you are not just pointing your phone at a square. You are decoding a complex digital message hidden inside a simple pattern, a powerful technology designed for speed, reliability, and convenience. If this video changed how you see everyday technology, imagine what else is hiding in plain sight around you. The world is full of invisible systems shaping your daily life, and we're here to uncover them all. If you want to be smarter every day, like and subscribe.